Hello everyone, welcome back to my channel. Today is day 1 of Azure Course series, and in this video we will understand the basics of cloud concepts, some of the most commonly used vocabulary and terminology in cloud computing. Okay, generally this video serves as a prerequisite before you start with any cloud platforms. It can be AWS, Azure or GCP. The concepts that I'm going to explain in today's video are the prerequisites for our Azure course. Alright, now I could have easily started with day 2 and start explaining you like how to create an account with Azure. But the problem is that if you don't understand these fundamentals, such as what is cloud, what is the difference between public, private, and hybrid cloud, or let's say you don't understand some keywords like what is an API, what is a virtual machine, then it becomes difficult for me to explain. Also, it becomes difficult for the beginners to understand the Azure platform or any other cloud platform. Okay. I mean, the same happens even if you're trying to understand the cloud platform through documentation as well or other videos. So that's why we will get familiar with these concepts that I mentioned here as well as the keywords that I have mentioned here, so that will be good to start with learning the cloud platforms. So please try to watch this video till the end. So let's start with understanding the cloud. Okay. I'll make it very simple. Even if you're a beginner, you will easily understand after watching this. So let's say in today's world, we all use applications like Instagram, Twitter, or any other applications, right? So these applications are developed on the developer's laptop. Like they are developed on the developer's laptop, right? Or the developer's machine, you can say. But for these applications to be accessible to everyone, like developer has developed on their machine, but we are accessing the Instagram on our mobile phones or laptops or our systems, right? So how can we access? So everyone are able to access these applications, right? So the applications have to be deployed on the servers. Right, when we use Instagram or Twitter, we don't use from the Twitter or Instagram's developer's machine, but we use it from the servers where this application is deployed. So what is a server? Typically, like server is also a computer, right? But the server has some local storage plus CPU plus RAM, and the purpose of the server is to run applications or processes. So for example, you can take your laptop, which is also a server. But your laptop is an advanced or the sophisticated, a rich server, which has a very good display. Your laptops might have a graphic card, right? But servers, they don't have these rich features, but they have the important ones. That is a local storage, CPU, RAM that are required to run the applications as well as processes. Now, why I'm talking about server? I'll get there. Uh, to understand cloud, you should definitely understand this. Like if you go 10 years back, now instead of Instagram, let's talk about Google or Yahoo. So there used to be a dedicated system admin or system administrators team whose responsibility is to procure these servers. Like, so there used to be, or even now, there are vendors like IBM, HP who sell these servers. So these system administrators, they used to procure multiple servers. Why multiple servers? Because let's say, like, let's talk about the system administrators team in Google. Like even 10 or 15 years back, before even the microservices concept existed, if you talk about Google, Google has multiple applications, right? Google has Gmail, Google has the complete G Suite, right? There are a lot of applications that Google has, and there are some thousands of developers, there are QA engineers, there are automation testers. So deploying these applications on one server does not work. So what the system administrators team at Google used to do is that they used to procure multiple servers. Let's call it as server 1, server 2, server n as here. And these servers, like today, let's say you access www.google.com, or even if you would have accessed google.com 10 years back, you don't get the response back in 15 minutes, right? You usually get response back. If you are talking about 10-15 years ago, probably we used to get response back in seconds. Now we get response back in fraction of seconds. That is because these servers that we are talking about, right, they are connected to these cables. Okay, servers are connected to cables. The system administrator teams, they used to procure these servers, like they used to connect these servers to high data transferable cables. Okay, high data transfer switches, cables to switches and switches to routers. So that's how these are connected. So system administrator teams, they used to procure these servers. They used to connect these servers to high data transfer cables, high data transfer switches, and from there all of these servers used to get connected to the routers. You got it right? So then these system administrator teams, they used to build this entire system. Okay, entire system where the servers used to be placed in some racks in this way. Okay, like you have racks in your wardrobes. So these servers were also placed in the racks, right? If you have someone who is working in the software industry from last 15 years or 10 years, you know, everyone is acquainted with this concept because they must have physically seen a server room like this. So this particular room where all of these servers are placed, applications are deployed on these servers, and these servers are connected with some cables, switches, routers. This entire setup is called as data center. Okay, and typically most companies used to have their own data centers. Like I'm talking about most, let's exclude the extraordinary cases, but mostly every company used to have this data center. So let's say this is the Google data center. Now, what is the advantage of it? Like I told you, one is system administrators team have built this servers. Now, let's say there is a developer called X, and this developer needs a server, right? So when this developer requests for a server, the system administrator team used to watch for all these servers, and they used to say that okay, this particular server is free, right? So you can use this part of this server, or you can use this particular server now. This particular thing is called as private cloud. You know, at that point of time, probably the word cloud was not that popular, but today we call this particular setup as private cloud. Okay. Probably for Google, it is very easy to buy a lot of these servers, right? For Google, it is easy to set up a system administrator team. For Google, it's very easy to buy these racks, connect them to switches, right? And not just it. Basically, the system administrator team, their job is not just done at this point of time. Like because they have helped the application developers to deploy applications on these servers, right? There are multiple challenges on this particular server room. Like it should have 24 by 7 electricity supply, right? Because if one of these servers does not have the electricity supply, then the application deployed on this server is not accessible. Okay. So let's take an example of google.com. Now let's take an example of some mid-scale organization, like having just 10 system admins. Okay, like 10 system admins. So it becomes very difficult for them, right? So second thing will be overhead. Third thing is continuous maintenance of this service, right? So the system administrators team, they have to continuously patch these servers. There can be some vulnerabilities on these servers, so they have to continuously upgrade the versions on these servers, right? There will be definitely operating system on them, so they have to continuously upgrade the operating system on these servers, right? So or if some cables are damaged, they have to make sure the cables are replaced. Or tomorrow there is some advanced cable they have to replace, so this cable should be replaced, right? So the third thing is maintenance. Okay, and there are many other challenges, not just that. And cost is another challenge, like maintaining all of these things is a very costly process. Okay, so these are the disadvantages of the private cloud. So now everything was going in this particular way, and then Amazon came into picture right now. So they said that we are starting something called as AWS. Now, why did they start this and what did they do? So they said that, so what Amazon said is, like, I know that it is becoming difficult for some organizations, like as we have seen the disadvantages right now. You can say that it is becoming difficult for some organizations, so let's take advantage of it. So what they said is, like, we are going to start something as AWS, and what we will do is we will set up our data centers, right? We just understood what is a data center, right? So Amazon, it will keep its own, it will set up its own data centers. So Amazon said we will set up our data centers across the world, as you are seeing on the screen right now. I'm not talking about servers. I'm talking about data centers here, which is collection of servers. Like this is like this entire thing is one data center, right? As we have seen, entire collection of servers is a data center. So then Amazon said we will set up hundreds of data centers across the world. There can be 5 data centers in the US, 2 data centers in India, 10 data centers in Europe region, 2 in Australia. And what companies can do is, like, if we take this particular company as an example, like XYZ XYZ company. So let's say this company is XYZ. So now Amazon said XYZ can come to us and request for 10 servers. And in Amazon, they are calling it as virtual machines. Right, I'll talk about this, don't worry for now. But what Amazon says is, okay, request for 10 servers and we will give you 10 servers. Now you don't have to worry about it, like if this server is secure or not, or if this server has continuous electricity supply or not, if the servers are continuously upgraded or not, all of the challenges that I have mentioned here, right? So don't worry, just tell us in which region, because we have data centers across the world. Do you want 10 servers in US, or do you want 10 servers in India or in Europe? Just tell me and we will give you those 10 servers, right? So here, this particular thing is called as public cloud. Now, these are the computers that are connected to each other, right? So if someone is requesting a server, they get a server from this cloud. In Amazon's world, these are the data centers, and in each data center there are servers, right? Anyone requests, they give you a server from this particular cloud, right? So they give you a server from this particular cloud, like, which is a connection of multiple servers, right? You don't know where you get the servers from, so that's why this is called as public cloud. And even in today's world, this is the difference between private and public cloud. Now you might ask me that in today's world, are there any companies that maintain their private cloud? 100%. Yes, there are some banking companies, there are some financial companies, and so on. Like, there are so many companies who needs their own setup. Like, because maybe because of some security reasons, or they have been using this legacy systems, right? The traditional old systems, and they have some data requirements, or they cannot move to the cloud because of the kind of applications that they are running. But typically, even today, there are a lot of banking, financial, insurance domains, applications, companies who are still running their applications on the private cloud. Okay, and there are some companies like who do not rely on the public cloud because of the security reasons, or because of like, they don't get the requirements that they have on the public cloud. Of course, there are so many public clouds like AWS, Azure, GCP. There are hundreds of cloud providers which typically fall into the category of public cloud. But still, there are certain requirements that these cloud platforms cannot generate even today. For that reasons, or for security reasons, or because they are running some legacy applications, there are some companies that are using private cloud. Now, finally, there is a concept called as hybrid cloud. So what exactly is hybrid cloud? Let's take example of a company called XYZ again. So this XYZ company said that, okay, we absolutely love Azure. So Microsoft has done similar job like AWS, and uh, Microsoft has set up their data centers across the world. Okay. And the XYZ.com said that they are located in Europe. And what they said is, okay, instead of setting up this entire data center and private cloud by ourselves, let us simply go to Microsoft and say that in Europe region, I want 100 servers. And the DevOps team, they simply ran some scripts and they got some 100 servers. And XYZ company has deployed their application on this 100 servers, right? Okay, now they got the servers, they have deployed their application, but after a while, like, the company, maybe because of some restrictions, they said that, okay, there is a very sensitive data that we want to store, and we don't want that sensitive data in uh, I mean, we don't want to give that sensitive information to Microsoft. We want to keep the sensitive information with us only. So what they will do is, they will set up a very simple data center, but it's not public. It's a private cloud, because this is in their premises. Like, it's their. It is also called as on premises. So they have this setup, on-premises setup, but it's a very small setup, and rest all setup where critical data is not there, so they will use the servers from Azure. Okay, so here as a they're using Azure for public services, and here as a private cloud they are using their own on-premises services for sensitive info. So it's a mix of private cloud and public cloud. That's why it's called as hybrid cloud, right? So don't get confused, like don't confuse yourself with hybrid cloud and multi-cloud. These days you might also hear about the things like multi-cloud. So multi-cloud is typically where companies use some services from AWS, some services from Azure, like they have mix of these cloud providers, then we call it as multi-cloud. It is different from hybrid cloud, of course. You don't have to worry about this at this point of time, because till now the goal is to understand what is private, what is public, and what is hybrid clouds, right? So I hope this particular concept is clear right now. And the next thing is to understand what exactly is cloud computing. So cloud computing is very simple. Whatever we discussed till now is basically cloud computing. Like if you're computing on cloud, that is, if you are running your applications on cloud, and if the applications are accessed by the users, so system administrators, now everything is DevOps engineers, cloud engineers. So whatever the task that these engineers perform and whatever the task that AWS, Azure, and the cloud platform that you're using together, this entire computing is called as cloud computing. So typically, every company today is performing the cloud computing because most of the companies are on the public cloud platform, or most of the companies are on the hybrid cloud platform right now. Okay, so let's move to these keywords. Like you don't have to worry about the goal is to get familiar with these keywords, okay, but not to get expert on these keywords right now, because in today's video it will be very difficult for you to become expert on load balancing, expert on high availability for now. So just get familiar with these keywords, and as we go on this series, as we understand day to day, you'll become expert, okay, on all of these things. Like towards the end of the course you will understand all of these concepts at an expert level. Okay, so now in today's video we will understand to learn basics and get familiar with these concepts. Okay, let's start with virtualization. Virtualization is a very simple concept. Like if you go back to the previous examples, whether it is private cloud or public cloud, let's say DevOps engineers or system administrators, they bought a server from IBM. Now obviously, like when IBM sells this server, like this server comes with huge configuration, right? Like it comes with, let's say, 512 GB RAM, right? It's not like your laptop which comes with 4 GB RAM or some configuration. Usually servers comes with some extensive configuration. Okay, extensive configuration. And you can say, let's say it comes with 512 GB RAM, and it comes with, let's say, 1000 CPUs, and no, I'm just making up this number. Don't have to think that, you know, these servers comes with these huge numbers. I'm just making up these numbers. Now the thing is that when these some servers comes with these configuration, obviously let's say there is a developer one, and this developer requests for a server. Okay, one developer cannot use the complete resource of the server, right? It will be a foolish decision if you allocate this entire server to this one developer. This cannot be accessed entirely by a developer. So whether a system administrator or a DevOps engineer does not dedicate the entire server to a developer. Previously, this used to happen, right? Then came the concept called virtualization, where virtualization is a concept like where DevOps engineers or system administrators The reason why I'm repeating system administrators or DevOps engineer, because back then there was nothing called as DevOps. Okay, when these concepts initially came up, so typically it was system administrators who are doing this. So system administrators on top of these servers, they used to install a particular software that is called as hypervisor. Now hypervisor is a software like that implements the concept called virtualization. Okay, so this is how it looks like. They install a particular software called hypervisor over the server. Okay, in a layman terminology, if you want to understand, if this is the server, what virtualization using the hypervisor software does is it will break the server not physically but logically. Alright, so a server is logically isolated into multiple servers. Like, so if it is 1000 GB RAM, using hypervisor, you can break it into 1000 logical servers. These servers are called as virtual machines, right? Because one developer might just need one or two CPUs to run their application, or probably four or six CPUs to run their application. So instead of giving them 1000 CPUs using this concept called virtualization and installing hypervisor on top of these servers, you can break them into logical 1 lakh, 10,000, any number of servers that you want. And the small logically separated servers are called as virtual machines over here, as you can see on the screen. Okay. In today's world, you don't do it because this is what Amazon does, right? In today's world, you don't have to install hypervisor by yourself unless like you're maintaining the private cloud infrastructure in your organization. But it is typically easy to understand, and I'm sorry, it is typically important to understand. Okay, so what Amazon does is, like I told you, they have the data center, right? Let's take one single data center that's in one of the US East region. So in East region, they might have multiple data centers. Let's say this is one of the data center, and like I told you, in this data center, they will have multiple servers which are connected using RxS, and each of these servers has huge configuration. So when one software engineer from company XYZ or ABC or a student who has an account with AWS or Azure, right, okay, let's say Microsoft Azure. So whoever has an account with Azure, even it can be a student, you can request for a virtual machine to them. And what Azure will do is, okay, a student has requested a virtual machine with one CPU and 2 GB RAM. So it will go to one of these servers which is set up with hypervisors. These servers are already set up with hypervisors, and these servers are logically split into multiple servers. So from one of these servers, it will just grant you one of the virtual machine, right? So whether it is Azure or Amazon or GCP, they all use this concept called virtualization, because their data center, although they have thousands of servers, but the virtual machine requests that they get, and because these servers are huge in size, they cannot give someone who is just requesting for one CPU and 2 GB RAM with this entire server that has this huge configuration, right? So that's why they use the concept of virtualization, and depending upon the request, they give you a server, right? So that's why virtualization is very important concept. Okay, so Amazon used this, Microsoft Azure used this to meet the requirements of millions of requests that they get on one single day. One single day, millions of people might request virtual machines from them, and this is how they generate those virtual machines. And in your organization, if you are maintaining the data centers, you also have to do it, because there will be thousands of developers in your organization who are requesting, and your organization just has some tons of servers, right? So this is the concept of virtualization. Now, the second thing that you have to understand is what is an API. Because I have already explained what is virtual machine, now let's try to understand what is an API. Okay? So again, a lot of people ask me this question, what is an API? I'll explain this in a very simple way. For any application that you take, let's take example of Facebook, or let's take example of any application that you have deployed in your organization. Or let's say you're working in an organization and your organization has an application that you have deployed. So there are multiple ways to access these applications. Like if you take Facebook as an example, you can go to your browser and you can just say www.facebook.com, and you can access this application. You can create an account with Facebook. You can talk to your friends, and whatever you're doing in this particular way, it's called as user interface, right? So typically you are accessing the Facebook application from the user interface. Now when you talk about applications, let's say DevOps applications. For example, if you have heard about Kubernetes, or if you have heard about Jenkins, right? So these applications also can be accessed using the user interface. Okay. Similarly, have you accessed Facebook along with that these applications? I mean, you can do it with Facebook also, but let's take better example, that is Jenkins. These applications can also be accessed using API or CLI. Now, what are these things? I understood was I understood what is a user interface, because every day I use Instagram, every day I use Facebook, and that happens through the user interface. But the application that you are writing, let's say the Jenkins application, the developers who wrote them, they will also allow to access these applications programmatically. Okay, because you are a user of Facebook, where you are just using it for watching some feed. You don't have to access facebook.com through some scripting or through some programming. But application developers, DevOps engineers, QA engineers who want to test facebook.com, right? They want to perform some scripting on the facebook.com, because they don't have to only test it through the user interface. They might want to test it for some scripts, for some errors through the scripts or programming for that application. For that application developers of Facebook, uh, they allow two different ways. One is through the API and one is through the CLI. So API stands for application interface, where developers, DevOps engineers, or QA engineers, whoever it can be, like even with Facebook, you can do it today. But if you ignore that in your organization, the applications that your developers are developing, they will expose the application using the API, so that someone can programmatically access these applications. So if you talk about Microsoft Azure itself, right? So in Microsoft Azure, like I told you, there will be different resources. Like you can request a virtual machine from Microsoft Azure, and to request this virtual machine in tomorrow's class, when you create an account with Microsoft Azure, you can go to your browser like Chrome or Firefox. You can click some buttons and you can request for a virtual machine, right? But what if in your organization someone wants to request 1,000 virtual machines. Clicking this 4 or 5 buttons 1,000 times becomes difficult, right? So what Microsoft Azure does is, okay, we will also expose something called API, and the developers or DevOps engineers or QA engineers, they can write a shell script or they can write a Python script, and we will provide you a API, that is the application interface. So if they hit this particular URL with some parameters, they can just say that I want 1 to 10, how many virtual machines you want, you can type it over there. So you will get those many number of virtual machines that you are requesting. Okay. So what you are doing here, programmatically accessing Microsoft Azure. So this programmatic way of accessing Microsoft Azure is called as accessing the resources of Microsoft Azure using the APIs, right? Simple thing that you have to understand at this point, if you are doing through the user interface, that is, if you are going to your browser and clicking few buttons to get a resource from Microsoft Azure, that means you are doing it using the user interface. But the same thing if you are doing using scripting like shell scripting or Python scripting, what you will do is you will talk to the API that is written by Microsoft Azure developers. And using this APIs, you can programmatically get the resources, right? When we use any particular application or resources on Azure. So this concept will become much better to you, but for now, just get familiar with this API. Okay. And the next concept is regions and availability zones. Okay. Now availability zones is very simple to understand. You can consider an availability zone as a data center. Okay. But what is a region? Because we just discussed about the complete Microsoft Azure servers and all, it will be very easy to understand. So assume this as the world map uh, with Azure data centers, okay, across multiple parts of the world. As I told you, so they have data centers in the US, they have data centers in India, they have data centers in Africa, multiple data centers in the Europe. So for Azure and even for people who are requesting the resources from Azure, there has to be a geographical identification. And there are some other significant things like, uh, let's say if you take an example, right? If you consider this as United States, and if Microsoft sets up all of its data centers in particular region of the US, okay? So if they have 10 data centers in US, if they set up all of these data centers in one particular region, let's say Alaska, okay, the problem would be what what if there is an electric shortage or electricity shortage, or there is some kind of natural disaster that has taken place in Alaska, and there is an lack of electricity supply to this particular thing. So what happens is Microsoft Azure servers stops working in the US, and the result of it is hundreds and thousands of companies who have trusted Microsoft Azure for keeping their data secure as well as for running their applications 24/7, because each application has customers, and the downtime in this particular area of US means downtime of complete Microsoft Azure, right? So to avoid that, what Microsoft Azure or any cloud provider does is, in like, instead of setting the data centers in one particular place in the US, what they do is they set up these data centers, probably like 5 data centers here, 5 data centers here. You can see on the screen, right? You can see like they put few here, few here, and they call this as a US East region, US West region. So that's how we need geographical identification of the regions, of the locations. That's called regions. And this is as so these are the US East and West regions. So even if something happens, right? Like even if there is a natural calamity or there is some disaster that takes place, and if complete US West is shut, if consider if US West is shut, which is quite rare. I'll tell you the reason why. There is still there is like US East, right? That is working. So the companies which are deploying their applications, if they deploy one application, I mean part of an application here and part of application here, even if this goes down, this is up and running, right? So their application might not work here, but it works here. So the request goes to this particular thing. How that goes there is a load balancer that is set up. We will go there, but for now just understand that the regions are created by Microsoft Azure or any cloud provider, because if there is some disaster that takes place or there is some natural calamity that happens and there is short of supply in one of the regions, still there is another region that works fine, right? Now I told you this is very rare. That is complete US West regions goes down is very rare, because even if you pick up one particular region, right? If you consider just US East region, right? So uh, here also this is very rare actually if the complete region goes down, because even in if you pick up one particular region, you can consider this as US East region right now. Even the data centers in US East region are created in completely far locations, if you can see, right? If there are three data centers in US East region, that is if there are three availability zone in US, you can say, if you consider each region is fairly set up. Each availability zone is fairly set up. Again, the reason is same. They are fairly set up because even if this data center goes down, this data center, if this data center goes down, if this data center goes down, but still you have this data center, this data center will be working fine and they're completely operational, right? So company XYZ, if they have an application, what they can simply do is they can deploy their application one part or one application here, right? And the other one here. So one application here and the other application of over there in this location. So they'll place a load balancer in front of it, so that even if this availability zone goes down, the load balancer will send the request here, right? We will come to the load balancer in a while, or let's talk about the load balancer. At this point of time, only because we are already talking about it, right? So what is a load balancer? If you go back to the same example, right? So in US East region, right? In US East region, let's say we have three data centers. We have three data centers. So what application developers, DevOps engineers does is they will deploy their application one replica here, and one replica here. Replica is nothing but the same clone of application. So what happens is they will set up a load balancer in front of it. What happens is they will set up a load balancer in front of it. So if there are 10 customers who are requesting the job of this load balancer, okay? If there are 10 customers, they are requesting for the job of this load balancer. If this load balancer gets 10 requests, okay? If this load balancer gets 10 requests, right? You can define, like you can design this load balancer in such a way, like you can configure this load balancer in such a way that you can tell load balancer multiple algorithms. Like you can say the load balancer send file requests to this particular server in the data center, right? And send file requests to the other server. Let's call this as one virtual machine, and in this particular data center, and let's say this as one another virtual machine in this particular data center. So you can design the load balance in such a way, if you get 10 requests, like if you get 10 requests, you can send 5 requests to this and 5 requests to this virtual machines. Or you can say uh, uh, the not just that, load balancers have hundreds of algorithms, right? So where you can say the load balancer that okay, send 20%, 20% here, and left of it 80% to here, right? So that's how you can configure the load balancer with different algorithms. Okay, you can configure the load balancers in such a way that if this virtual machine goes down, right? uh, if this virtual machine goes down, all the requests goes to this virtual machine itself. Okay, let's say this availability is went completely down, and this availability so this virtual machine has gone down, and the load balancer automatically starts sending 10 requests to this particular thing only. Okay, so load balancers are that powerful and they have a lot of capabilities. We will understand about all of the capabilities once we talk about load balancers dedicated video. But for now, understand the advantage of load balancers is to split the load, because um, in Instagram, you can say totally today millions of users use load balance Instagram. And if all the millions of requests just go to one particular application, that application will die because of the number of requests it is receiving. So load balancers are created. They are placed in front of 2, 5, 10 replica. Because of your application, and the job of load balancer is, if it gets 1 million requests, it can send 10,000 here, 10,000 here, 10,000 here. And if unfortunately one of the server goes down, immediately it will understand and it will stop sending requests to this particular server. and then probably it will send 20,000 here, 15,000, 15,000. So such powerful load balancers are, and in the world of public cloud where applications are deployed in multiple availability zones or data centers, load balancers plays critical role, you know. Okay, so that's how you can understand the load balancers. Now, next topic that we have are the features of cloud computing, like scalability, elasticity, agility, high availability, disaster risk recovery. So I'll complete this next. So what is scalability? In the world of cloud, we are just getting familiar with these topics. So we don't have to drive deep right now, but understand for now, just understand that as we use Instagram, right? Or let's say you're watching the cricket match, or you're watching the baseball match in Hotstar, or any particular application. Okay. So what happens is sometimes there might be 10 million users who are watching this particular thing at one point, and drastically this goes to 25 million. The number of users who are watching it, sometimes it goes to 40 million, right? So the thing is, so the thing here is like uh, when the number of users are increasing dynamically, or this can be a static increase also sometime. You might expect this particular thing, or sometimes you might not expect this particular thing, but there is an increase in the number of users and increase in the number of requests. So initially, let's say you have created multiple copies of your application and deployed in 3 virtual machines. Okay. You have deployed multiple copies of your applications in these 3 machines. Let's say you have placed a load balancer. Okay. So this is copy 1. So let's say this as VM1, and this is VM2, this is VM3. Now we have created 3 copies, and you said, okay, if there are 10 million requests, then 1/3 here, 1/3 here, 1/3 here. Now I'm just making up. There will be multiple copies. Just understand that this is how it is configured drastically. If it goes to 25 million, if you send 20 million requests here, 15 million requests here to the application might not serve, right? And what will be the result of it? There will be a slowness in the application, and if you're watching a particular match, you will not expect the slowness, right? You will not take it for granted. So for that particular reason, what we will do, or what the DevOps engineers do, right? So there is a concept called auto scaling, right? So auto scaling means you will tell the Azure platform, or you will tell the AWS platform, whenever whichever cloud platform you're using it, they will have the auto scaling services, where you can say auto scaling service that, okay, if this virtual machine is occupied, you can automatically scale one more virtual machine. So on you can do. So on you can do till the requirement, like till how many you want, you can do it as per the requirement. Like if this virtual machine is occupied, you can automatically scale one more virtual machine and deploy the application, right? So if you need more requirement, then scale one more, and load balancer will automatically identify, and it will automatically add these servers. Okay, so the load is automatically managed, and this mechanism is called as auto scaling, right? And if you want to do it manually, in some cases you don't want to use this particular feature of the cloud provider. If you do it manually, then it is also called as manual scaling. And this particular capability or this particular feature of cloud computing is called as scalability, which is very important. Like here, scalability is again a very simple concept. Like I have explained scaling your applications load balancer. If you understand that concept, it's very simple. Usually if you have 10 people requesting or 10 people sending requests to your application, initially you might feel two virtual machines are enough. You have deployed one copy of your application in one virtual machine and another copy in another virtual machine. Okay. And send 5 requests here, send 5 requests here, right? And immediately when the application request goes to 20, 30, probably sending 15 here, 15 here might work. But what if request immediately goes to 10,000 because it is some Christmas or some festival, anything? So if the request goes to 10,000, this cannot withhold with your traffic, right? So immediately your infrastructure should be in such a way that it has to scale new virtual machines and automatically it has to deploy in those virtual machines, right? So this is the concept of scalability. Now sometimes you might have heard people talking about scalability, like making your application scalable. That means this is the thing that we are talking about. Make your infrastructure scalable. When someone says make your infrastructure scalable, that means this is what they are talking about. It can be auto scaling, it can be manual scaling. Of course, in scalability, there is one more concept called as horizontal scaling and vertical scaling. We will come there. You don't have to learn that at this point of time for now. Just understand the concept of scalability. Then the next thing is elasticity. The other name of elasticity is nothing but dynamic scaling or auto scaling, right? I have told you there are two parts of scaling. One is manual scaling and auto scaling. The infrastructure to is you scale it dynamically, which is auto scale, or dynamic scaling is also called as elasticity. So whenever you hear the term called elasticity, don't get scared. Uh, they are talking about automatic scaling. Okay, your infrastructure perfect. They are talking about automatic scaling, automatically scaling your infrastructure. Okay, perfect. Then comes high availability. Now, how now high availability. Okay, you just need to understand at a broad level at this point of time. High availability is like making your application available most of the times. Okay, best example is Instagram. You can see Instagram rarely going down, right? Or Facebook, rarely you see Facebook going down. Let's say some bank applications. You might expect the banks to have scheduled maintenance. You might expect the ticket booking applications to go down. But if you look at Instagram or Facebook or any particular application, that they rarely go down because they have high availability infrastructure setup. So, when someone is talking about high availability, understand they're talking about infrastructure that requires the applications to be highly available most of the times. Okay. So, let's now talk about disaster recovery. What is disaster recovery? So, again, disaster recovery means it's called DR. Disaster recovery is a technique, okay? It is a mechanism where you need to have a plan, action. Like if something goes wrong, right? Uh, Disaster recovery means a disaster has taken place. Now, how do you recover from that particular disaster, right? So, you might do a lot of things for making your application secure, safe. Your application should not go down. But what if it goes down? You need to have a disaster recovery plan. so that disaster recovery is like having a backup, right? So when we are dealing with the cloud platforms like Azure or AWS, although they have very good SLAs that they have promised, that if they that they give a lot of promises to you, right? So although they are mostly stable, but let's say you have your users data in one of the databases. Okay, consider in Azure platform. In Microsoft Azure, you requested for a database. Just like you request for your virtual machine, you can also request for a database. And in this particular database, like you started storing all of your users' information, right? And for some reason, this database goes down. Again, the same thing probably, the availability zone has gone down. You have to make sure you have a backup. What is a backup probably? You will store it in another availability zone, or the best thing is store in completely different region itself. Let's say you have one copy of database in the US East region, probably create another copy in Singapore just as a backup, right? So such plans are called as disaster recovery. So, as a DevOps engineer, as a cloud engineer, you should always think about disaster recovery. Now, why did I cover all these topics? Like you might be feeling that for today's class, this class is very long and you talked about a lot of concepts. Some of these things might go above your head, but as I keep repeating these words, you'll get familiar with it. Probably when I explained about scalability, some of you might have not understood, but that's fine because at least we are getting familiar with that term. And in future classes, we will get expert with it, right? And next classes, the concepts will be very straightforward. You will not learn so many concepts in one single day, but because this is a prerequisite class, my idea and intention is to make you familiar with these concepts, right? So at least get acquainted with the terms like virtualization, virtual machine, API, regions, availability zones. I'm pretty sure you people might have understood till here at least. So other concepts should be pretty much easy to understand, and I hope this entire class sounds informative for you. And going ahead, this plays a critical role and serves as a prerequisite. So please let me know in the comment section what did you feel about today's video. If it is lengthy, let me know, or if you find it informative, also let me know. Okay, thank you so much for watching the video. Take care everyone. See you all in the next class. Bye bye.